Hello. Am I audible?
Yes, sir.
Yes, sir.
So, good evening to all of you.
Good evening, sir.
Okay, so today we will see the concepts from week 7. Okay, majorly we will focus mainly. So I'm going to give you some idea about content related to week 7, which is basically this probability and like what is the basic experiment, random experiment, outcome, trial, and if it is the probability, then how we can see, how can we can visualize, and we will see the Venn diagram, and we will see some rules of probability, some conditions of probability. All of these will see in today's session. Meanwhile, uh, just to get an idea, how many of you watched the content of week 7? You can raise your hand, or else at least you have covered 3 videos. That's all. Those you can raise.
Yeah.
So, one, two, four, right? Four of you have watched. I have covered at least three, five. Okay.
Excuse me, sir.
Yes.
Before you start session, I wanted to ask you about something. Uh,
Something what?
Sir, actually, I was seeing the grading system. In
Hmm.
that, there is a section of OPPE, and the date it is showing that it will be held on 21st of July.
Hmm.
I wanted to ask you what is this OPPE, sir?
So you are currently in first term, right?
Yes, sir.
Yeah, that is not for you. So just read the grading document carefully. So OPP is called online proctored programming examination. So those, suppose you have Python, okay, then there is OPP exam. You have other courses, let's say machine learning practice. When you will enter, second semester of the course, and when you will enter in diploma level, then you will get. So if there is any OPP and all, you will get the notification. Now it's not like exam will be conducted and you are not aware about that. So no need to worry about those kind.
Okay, sir. Thank you.
Okay. Okay, so I can see only three, five or six. So
Sir,
rest, you haven't seen. Okay.
sir, I have one doubt, sir.
Hmm?
Sir, can I drop from mathematics course? But as of now, I had paid fees for 3 subjects. Can I?
Okay, yeah. So these kind of general and ops related doubts, support team will help you. Okay.
Okay, sir. Thank you.
So sessions here we is basically for to discuss the technical things. Okay, so let me share my screen. It's already 8. Okay, so I'm going to share my screen.
Sir,
You,
excuse me.
yes.
Sir, can I ask something? I have one doubt in the week 6 graded assignment. So can I ask now?
No, no, no. It's due date is still pending.
Today is the due date.
So after due date, we can discuss the graded assignment. Okay.
Okay, sir. Okay.
Yeah. Thank you.
So you are explaining the concept of week 7,
Excuse me.
right?
Yeah. So I'm going to start the content of
Sir,
week
so
7.
can you mute
Sir,
everyone,
excuse
or
me.
there should not be no disturbance.
Yeah, sure. Okay. So it's a request to everyone. Okay. Please mute yourself. Okay. So, okay. So I'm going to start the discussing the concept of week 7. We'll try to focus. Okay. So we'll start. What is the basically probability part? Okay. Before giving the definition of probability, I'm going to write some example. Okay. So I'm going to write some example. Let's say first I'm going to write. Just give me a second. Let's say I'm writing uh, something like okay. Let me write like this. Let's say I'm saying there is a high chance, you know, of uh, by getting the job, let's say, next month. Another example, let's say I'm saying, let's say there is, sales managers. Okay? Suppose a sales manager cannot predict with certainty about the sales target next year. Okay. At the same time, suppose I'm going to write a third scenario. Suppose I will say more everyone is aware about the cricket match and IPL. So let's say you are saying there is a 60% chance that India will win the match. Okay. And at the same time, you can say, suppose you are giving an exam and you can say your, like you say, my guess is, answer A is the correct choice. And again, I'm just taking another exam. Let's say, there is election is going to happen in your society and all. Then you can simply say, yeah, this party, let's say party XYZ, will win the election. Or let's say will probably win the election. Okay. Or you can say upcoming election. Can write. Another you can say, let's say there is a uh, you can say simply some let's say you are saying 30% chance, okay, of raining tonight or something like that. So if you see all these scenario means this there is a high chance of by getting the job next month or next year whatever, and a sales manager cannot predict with certainty about the sales uh, you know target next year, and there is a 60% chance that India will win the match. My guess is answer A or B is the correct choice. Party XYZ will probably win the election. There is a 30% chance of raining tonight. So if you will focus on all these statements, so all the above statements, so there is three things, right? So like all the above sentences, right? You can say so. There are those sentences. There is three kinds of words, right? So it includes the words, possibly, and there is a word of high chance, right? And you can say likely, okay, something like that. So what are these things basically? What you can say something? What are these things? Can you say something? Just think. What are
It's
these
like
things?
the percentage.
Probabilities.
Yeah, I've come to probability. So basically, okay, just can I say these are the
It's not fixed, yeah.
Sir,
yeah,
assumptions.
They are
okay.
uncertain.
Okay,
Sir,
just correct me if you okay. Just tell me
Predictions. We are
whether
making
you are
predictions.
agree with me or not. Can I say these are the basically expressions?
Predictions.
Okay, these are the basically expressions which indicating degree of uncertainty
Yes, sir.
Yes.
about
Yes,
what?
sir.
About the happening of the event.
Yes. Possibilities.
Correct. So okay, would you agree with me this statement which I'm going to highlight with this red part, right? So these are
Yes,
what?
sir. Agreed.
Basically expressions which are indicating a degree of uncertainty, right? About the happening of the event, right? So all are the about the we are talking about the uncertainty about happening of the event. Okay, you can see whether I'm talking about 60% chance that India will win the match, or there is a 30% chance of raining tonight, or something else, right? So basically probability, these all things were okay. So but this is something you cannot talk something, just verbally, right? So to okay, for this scenario, we should have something, right? We should have something numerical measure. I mean, we should have something measure which can, like, for this kind of uncertainty, yes or no, right? So basically, a numerical measure of uncertainty, I can write a numerical measure. So these kind of things we should, there should be something, okay, like a numerical measure, I can say, of uncertainty. So this numerical measure of uncertainty is provided by, basically, this is called theory of probability. Okay. So, Saurabh, please mute. So if you do not have anything, so something, so please. So okay. So basically, we will. So there is a numerical measure of, for this uncertainty, that's called the, we will see under, theory of probability. Basically, so in theory of probability, there are three kind of, like, possible states of expectation. Okay. So under this we have what kind of possible states of expectation will be, okay. Uh, so, like, possible state of expectation can be, so there will be three kinds of things, right? That will be certainty, okay, and another will be impossibility, yes or no, and third will be, probability. Would you agree with me? So
Yes, sir.
for certainty, we will be having probability 1. For impossibility, that means 0. And for the third stage, this probability, the various grades of us, I mean, you basically, what will be the case? So you can say your uncertainty, I'm writing uncertainty, will lie between 0 and 1. Correct? Not equal to.
Yes, sir.
No, okay. This overall rough idea is okay. So for, to understand this theory of probability, will always be having these three possible states of expectation. Whether you will be for, like, sure, and there will be impossibility, or there will be some probability, or there will be some chance. Yes or no? Okay. So basically, for certainty, you will be sure, that is 1. For impossibility, there will be 0. And for probability, your uncertainty will lie between 0 and 1. Okay. So far, so good.
Does this mean like certainty's value is 1 and impossibility is 0 and probability will
Correct.
lie?
Correct.
Okay,
Correct.
sir.
Correct. Okay. So probability, yeah. So here you can include equality also, because if I'm saying probability is 0, that means I'm talking about impossibility. Okay. Overall, you can, yeah. Okay. So basically, so what probability says here, basically, so I'm just like, basically, the determination of, I told you, right? There should be some numerical measure for uncertainty, right? So basically, we are going to check the determination of chance, right? That an event will occur is the matter of probability. Okay. So these all things we are going to see with the, some numerical measure. So that is something we can see with the probability. Okay. So some till now some sort of idea is okay to all of you? Yes, no? Like,
Yes, sir.
why probability
Yes,
is
sir.
necessary or important for us in, real life case. Okay. Is
Yes,
it
sir,
clear?
it's clear. Yes, sir.
Okay. All right. So now we will, okay. So maybe if you can recall from week 1,
Sir,
we saw, yes.
sir, in statistics, one in earlier lecture, in particular lecture, there was a place in Excel, right? So their ma'am referred that in a cricket match, let's say there is a player who have never ever means a ball in their life, so that couldn't be counted as zero, but so it was bad, so there was something like not defined. So
Yes, yes, yes. That those all things we'll see. Yeah, there is something impossible, right?
yes,
Suppose I'm saying anything, right? Suppose I'm saying you are tossing a coin and you are getting something one.
yes,
Okay, that's impossible. Okay, you will get zero. Okay,
Correct.
probability for impossible event is zero. So I will discuss all those things. Okay, don't worry. Okay.
okay, got
So
it.
basically, if you see, so where probability helps us actually. So if you see, if you can recall from week one, we have seen maybe descriptive statistics, and don't ask me now what is the definition of descriptive statistics. Okay, and you have seen the inferential statistics. Okay, so in descriptive statistics, what we are doing, we are just simply describing the data. But for inferential, if you see what we were doing, we were making the conclusion, or we were making the inference, right? What is that inference? Correct. So for that, what we were doing, whenever we have descriptive statistics, right? And if we are moving to inferential statistics, so if you can remember, I can say, right, there is 80% chance India will win the match, right? So how we are saying, based on the previous data, something like that. Correct.
Yep.
So there is a in between factor that's called the probability. Okay, are you getting? In inferential we are making conclusion, right? So that conclusion, for that conclusion part, there is a factor of chance, you can say factor of likelihood. Okay, what is the chance that that particular event will occur? What is the chance, let's say, even rain, there, I mean, there will be raining tomorrow or tonight. Okay, what is the chance I will get job in next month, something like that. Okay, so these all, if we are going to determine this chance with something numerical quantity, so those all things we can understand with the help of probability. Okay, so far so good.
Yes, sir.
Yes, no, okay, fine, yeah. So this is clear to you. So let me define some basic definition which we need to understand before moving in further in probability part. So first is experiment. Okay, so as the name suggests, very easy to understand. So an experiment is nothing but, so an experiment, basically I will write the definition so that it will give you an idea. An experiment is basically is any process. Okay, that process can be anything, but that process produces an observation or outcome. Okay, so experiment is something that is any process, and what kind of process that produces an observation or outcome. For example, if I'm say let's say I will say experiment can be something like that. So suppose I'm saying my experiment is I'm going to measure the lifetime of bulbs. Okay, so experiment will be measuring the lifetime. So let's say lifetime I'm talking about in terms of hours. Okay, of the of a bulb. Okay, so this is the experiment, right? So that experiment should produces a outcome, right? So what can be possible outcome? So outcome can be 0 or 1 hour or 2 hours and so on. Yes or no? Correct. Okay, so see, bulb can be
Yes,
like
sir.
lifetime can be anything, 0 hours, 1 hours, 2 hours and so on. Okay, another let's say I'm saying suppose experiment is something like this. Suppose you are giving an exam. Let's say you are going to give an exam of quiz 2. So guessing answers to a, let's say, 4 option
Multiple choice question.
MCQ. Yeah, multiple choice question. Okay, so what will be the outcome for this case? It can be, let's say there are 4 options A, B, C and D. Yes or no?
Yes,
Because
sir.
so these
Yes,
are the
sir.
experiments. So this is, it can be anything, tossing a
So, sir,
coin.
experiment can be a case.
What do you mean by case?
Like, sir, like a statement of like we are like how, based on what we are deciding our outcome.
No, it's not like case. You
I'm
can
not
say,
talking about variable or case, sir. I'm just
huh,
talking about like a simple normal case.
that is something. Yeah. So basically, experiment. If you see, that should be a process. This should produce, some result, some outcomes. Okay. Let's say you are going to throw a die, right? So if you're throwing a
Some
die,
random experiment.
so okay, I didn't talk about till now random experiment. I will come to that. Okay. So throwing a random die, you can say simply, you will get the outcomes 1, 2, 3, 4, 5, 6. Okay. So these are the things about experiment. So it's a process that should produce an observation. So let's talk about next, that is called something, random experiment. Okay. So what is the basically a random experiment basically? So this is the random experiment is nothing but it's an experiment also, but whose outcome is not predictable with certainty. Okay. So okay. So random experiment is basically a random experiment is an experiment whose outcome is not predictable with certainty. Okay. So like you means outcome of any random experiment, you can't predict with certainty, but you will be you will know I mean what the possible outcome can be. Okay, for example, suppose I'm saying, you know uh, tossing of a coin, correct? So if you are going to toss a coin, either you will get head or you will get tail. Yes or no? These are
Yes,
the
sir.
two possibility, but you cannot predict what will be the outcome, right? With certainty, you can't say, yeah, now with you can't predict this certainty. A head will be there. Yes or no?
Yes, sir. We
Okay.
can't.
Yes, sir.
Yeah. Similarly, random experiment, you can say, suppose I'm saying,
Sir, throwing a
uh,
die, sir.
yeah, throwing a die, correct?
Chances of getting 1, 2, 3, 4, or 6.
Correct. So what are the possible outcomes, right? So these are the possible outcomes. You know the what are the possible outcomes, but you cannot predict the outcome with certainty, right? You can't
Yes,
you
sir.
can't say one will be there. You can say with probability, but you can't say with certainty. Yes or no?
Yes, sir.
Okay. So these are the experiment we come under.
Predictability means
Sorry.
experiment who has the outcome is not predictable within the
See, outcome is not predictable
predictable
with
means
certainty. See, means suppose you are tossing a coin. Okay. If you are going to toss a coin, you cannot predict the outcome, right? Like,
your your voice not good, sir.
is it? I think,
No,
is
no,
it
no.
okay?
It's
It's clear,
clear, sir.
sir.
It's
It's
Clear,
clear.
clear.
right? I
It's
think there
clear,
is
sir.
some issue with your network. Please check. So, like random experiment is something like whose outcome you cannot predict with certainty.
Sir, I
This
have a question in this.
throwing of a die. Yeah, this good.
Sir, so sir, random experiment, like sir, the probability of like we can't be certain. So sir, how can we like differentiate between random experiment and normal experiment? Because sir, they all are the same. Like
No, no,
sir,
normal experiment is not. See, there will be some experiment which are deterministic.
can you give some example of it?
Okay, okay, just think a little bit. Okay, so okay, for example, suppose you are there is a okay, what I will tell you. Suppose there is a let me write here. So, mean you can say suppose there is an object. Okay, and so deterministic means, see, deterministic, I told you, right? So deterministic means any kind of thing where chance is not there, right? You can say like you can determine the outcome with
Tossing a biased
certainty.
gun.
Like
Sir, like,
no
Tossing a biased gun.
sir, actually,
bias. Hmm.
random experiment, sir, actually is like when we have a more than one possible outcome, and like deterministic, sir, it has a only one outcome.
One,
That
yeah,
means,
correct. So, for example, you can take any example from physics, right? So, if you'll take, you can take the examples of, yeah, suppose if you release a pendulum from a specific height and angle, then the motion of, motion of the pendulum, you can precisely predict, right? Yes or no?
Yes,
Or
sir.
you can talk about any chemical reaction like reaction with hydrogen and oxygen. I mean, okay, if you'll take a reaction of hydrogen and water, sorry, oxygen, that will produce water, right? Let's
Yes,
say
sir.
Yes, sir.
I
Yes,
will
sir.
say 2H2 plus O2, it will give you 2H2O, right? That is
Yes,
something
sir.
we have seen already. So this kind of experiment called the uh, deterministic experiment, where you can predict the outcome. Okay, but in these kind of cases, you cannot predict the outcome with certainty. Here you will predict the outcome with sure. Yes or no?
Yes, sir.
Or any
Yes,
any
sir.
physics law, you can say, suppose this object is here and with some speed and time, that okay, let's say this object will be here in with this speed and this time limit, this object will reach here, something like that, right? So you will be sure. Are you getting my
Yes, sir.
idea?
Yes, sir. Yes, sir. Yes,
Yes,
sir.
sir.
So this kind of experiment will come under the deterministic experiment. What is the experiment? Basically, any process that produce an outcome. So this is also a process, right? This is one of the process, right? But this
Yes,
will
sir.
produce a outcome.
Certain outcome.
Again, this is a process. This is a process, moving process, and this will produce a outcome. Okay. But
Yes,
what
sir.
is the random experiment? If you cannot predict the outcome with certainty.
Yes,
Now
sir.
it's clear. Okay.
Yes, sir.
Okay. So next is called something called sample space. Okay, in probability parts. So what is the sample space? This we have seen. If I will do any experiment, that will I mean that will produce some outcome, right? So and so what is the definition of sample space actually? So sample space is nothing but collection of the all possible outcomes.
outcome.
Okay.
Yes, sir. The set of all
So
possible outcomes of a random
correct.
experiment.
So sample space is nothing but collection of all possible outcomes, okay, of a random experiment. So basically, what? Okay, suppose I'm saying I'm going to toss a coin. Okay, so normally sample space we are denoting with S or omega. In some book you will see S, some book you will see omega. So doesn't matter. We need to clear with our concept actually. So what will be S here? Sample space will be, if you are going to toss a coin, then what will be the possible outcomes?
Head,
Heads or
head,
tail.
Sir,
tail,
Head
head,
and tail.
head or
Head and
tail,
tail.
sir.
head,
Yes,
and
sir.
tail.
So these are the two possible outcomes. Correct.
Yes.
Okay. If suppose I'm going to suppose I'm saying tossing a coin twice, then
Sir,
what we say?
sir,
Head,
head,
head.
head
Head,
and tail,
head,
tail.
head, tail, tail, head, tail, tail.
Head and tail.
Yes.
Correct. So I will get head, tail,
Head, tail, and tail,
tail,
tail.
head, tail, right? These are the possible outcomes.
Yes,
Okay.
sir.
Suppose I'm saying uh, throwing a die.
So then 1, 2,
1,
3, 4,
2, 3,
5.
4,
One,
5,
two,
6.
Six
three,
outcomes.
4,
Six till
5,
six.
6.
Okay. Now it's clear, right? So basically, what we are going to do, we are this is just a collection of all the possible outcomes. Okay. Fine.
Sir, in the first like toss a
Yes,
coin,
sir.
Mhm.
we did like H and T only. Like, why didn't we did like T and T? Like, so this means like we have to just like uh say the possible outcomes. Like,
Correct, right? These are the possible outcomes, right? So suppose you are in reality, you toss a coin, you got tail. That's the different thing. But what is the possible outcomes? These are the only possible outcomes, right? So we are
okay, sir.
talking about possible
Yes,
outcomes.
sir. That's what I was asking.
Correct. Yeah. Okay. So basically, there is something. I think let me talk about event. Then I will come to that point. There is something called disjoint and uh, mutually exclusive and all. So let me define
The,
the event basically. Yes.
the sample space is always drawn for random experiment.
Yes, yes, yes.
Okay.
Yeah, in terms of probability, it's a collection of all possible outcomes of a random experiment. Okay. Fine. Okay, so let me talk about the definition of this part. Okay, so before going to that, can you tell me what will be the sample space if I'm saying no, measuring the lifetime of a bulb? Let's say in hours of a bulb. So what will be the sample space? Anyone can guess?
It's continuous wave.
Okay, so I can say, suppose I'm going to represent with the x such that it should be greater than equal to 0 hours, and it can last anything. We don't know the upper limit, right? It can be for 4
Yes,
hours,
sir.
40 hours, 60 hours. It can be anything. Okay, fine. Okay,
Yes, sir.
yeah. So let me define the event. Okay, so what is the event? Event is very basic thing. So event is you can if I will talk about it in basic terms, it's a subset of the sample space. Okay, this is event is a subset of the sample
Sample
space.
space collection of all outcome
Correct,
denoted
correct,
by the
correct,
0 or 1.
Possible outcomes.
correct, correct. Denoted by S or omega. Okay. So what is the event basically? What is the can you mute? There is a background. Yeah, thank you. So event is something. Let me talk. Let's say I'm saying I have, suppose I'm going to take an experiment, random experiment, you know, tossing a coin twice. Okay. So what is the sample space? It can be HH, HT, TH, and TT. Okay. This is the sample space. So what is the event? Event is just a subset of this. So suppose I'm defining event E or A, you can define anything. So E is such that or E denotes you are getting exactly one head. Suppose this is the event. So what will be the possible outcomes for E now?
Head,
Head, head,
head,
tail,
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 tail.
Three
No,
also.
head, tail, and tail head
Two
only. Because I'm
outcomes.
talking
two
about
Outcomes
exactly one head.
completely.
I did
Two
okay.
outcomes.
If I will say, let's say I'm defining events. Let's say this is E1, this is E2. E2 is such that at least one head. Then
Three
what will be
outcomes.
possible?
three outcomes.
Three outcomes
Three.
possible.
So at least one means there should be more than one, like one greater or equal to one, right? So HT, TH, or HH.
Head,
Okay. So suppose I will say event E3 denote exactly two head, let's say two tail, then
one outcome.
it
One
will be
out.
Is
TT, right?
tail
So
head.
you can say all these, you can see basically all these are what these are the subset of these things, right? This sample
Yes,
space.
sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay. So subset is what like I will say two
Event.
events. Yeah, let me write the definition for subset as well. So subset is what for any two events. Let's say I have two events E and F. Okay. If all the outcomes of any event, you can say, let's say if all the outcomes in E are also in F, you can do in vice versa also. Okay, that's not a problem. We need to just, then what I will say, then we say that E is contained in F. Then I will say event E is contained in F. Okay, or I will say this is same as E is subset of F. Okay, at the same time, what is the notation? So E is the subset of F. This is the notation. Okay, so what is the definition? Is suppose there are two events E and F. If all the outcomes in E are also in F, then I will say E is contained in F, or else you can say E is a subset of F. So here you can see
So can I say here E1 is the subset of E2? Because all the elements of E1 are contained in E2. Would you agree with me?
Yes,
Yes,
sir.
sir. We can say.
Yes, sir.
Yes,
I can
sir.
say, right? So that is the meaning
Yes,
of
sir.
subset, right?
Yes, sir.
Okay. Okay. Can you say E3 is a subset of E2?
Yes, sir.
No,
E3,
sir.
No,
No,
sir.
No,
No,
sir.
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 We can't say
right?
that.
Sir.
Now,
No,
can I
sir.
say, okay, now can I say E1 is a subset of S?
Yes.
Yes,
Yes.
sir. We can say that.
Yes,
Yes,
sir.
sir.
E2 is a subset of S?
Yes,
Yes,
sir.
sir.
Yes.
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 E3 is a subset of S?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Yes.
S is a
Yes,
subset
sir.
of itself,
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Then
correct?
equal
Yes,
to.
sir.
Yeah,
Yes.
basically
Yes,
it
sir.
will be something equal to, yeah. Okay,
Proper. Sir.
correct? Proper subset. Now this is clear, right?
Yes, sir.
Yes, sir.
Okay. Now, so we saw the event. Event is what? Which is the, okay, can I say, okay, for that example, head, 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 tail, tail, head, tail, tail. Okay. Can I say, okay, can I say five, five? Okay, before that, let me define null event. Then it will be clear to you. So there is something called a null event. So what is the null event? Basically, we call the event without any outcomes. I mean, null event is something, the event, okay, there is an event without, any outcomes. Okay, that's called the null event, and we can denote it basically by 5 or simple, you can say like without any something
Empty set.
Sir,
empty.
for coin, there is no null event, na?
No, it's
Yes.
not like that. See,
Coin toss result in neither head or nor tail. So
correct.
it is null.
Sir,
So
can it be possible like where if it's not head or not tail?
Only movies.
that's not about
Sir,
movies.
if we don't toss any coin, then it is possible.
No. If you see to finding, like examples of anything, right? Null event or whatever. So you should do some experiment. Like only then. So you can think like which is kind of impossible event or something like that. So for example,
A
you can
toss that
say,
shows both head and tail.
sorry,
A toss that shows both head and tail.
both head and tail. Yeah, that is the
That's an
impossible
impossible
event.
event.
No,
Yeah,
no.
that
Yeah.
is the impossible event. Yeah, you can think something like that, something or different also.
Suppose
Hmm.
suppose
A dice
there's
showing
a fruit
7.
basket.
Sorry. Let's
It's
see.
dice showing
You can
7.
think in different way also, right?
Suppose we
Apart.
are having a strawberry and a watermelon, and we have to choose banana, sir. Like we do not have any
Correct.
choice.
So basically, null event is what I told you, right? It's basically you can say empty events, right? So that doesn't contain any elements. Okay. For example, someone told me that example of tossing a coin. Okay. In that, I forgot the name. Can you tell me your name, please? You told neither head or neither tail, or
Sir,
right?
me, sir.
So
Vishwari.
high like that, sir.
Sir,
Yeah. Okay.
Vishwari, sir.
Okay. Yeah. Great. So you can say neither head. If I'm saying I'm going to toss a coin and toss results in a toss results in what? Neither heads nor tail. Okay. So this is
Sir,
what?
a natural number less than 0.
Yes, a natural number less than 0, or else okay, let me, yeah, correct. Natural number cannot be less than 0. Okay. So
Prime number greater
this
than.
is the null event, right? You will
Yes, sir.
not get any element. Okay.
Yes, sir.
Let me take
This event
suppose
does not.
hmm,
Yes, sir. This event
So
does not
we
consist of any event or set of events from the I mean from the sample space whatever we have taken.
complement of sample space.
complement, yes, correct. So complement, I will come to that complement point actually. So in sample space, it will contain all the possible outcomes, and complement will contain doesn't. Okay. Let me take another example that will clear also. Suppose you are rolling a die And what is the thing? Suppose you are rolling a die, and I will say you are getting a number
Greater than 6.
yeah greater than 6. Yes or no? So this is null event, correct? Suppose I'm saying
It will
another.
be a impossible event also.
Sir, just like
Yeah,
rolling, if rolling a die and it's stuck in a hole of the table, sir, then we can say that null event.
that is something. Suppose then you'll say you have a coin and you have painted with black color on both sides, you are getting nothing. So that those are things we can like. That is
Sir,
something we
these
are doing
kind of
some
questions are rare,
manipulation.
right,
Okay.
sir? Like, will,
Okay.
sir?
No, no.
Finding
See,
a bike with three tires.
we need to understand what is the limit. I will tell you why in a minute. Okay? So basically, suppose I am saying the set of odd, natural numbers, okay, which is divisible by 2. So this is what? Impossible event?
Yes, sir.
Impossible
Correct?
event.
Something like so. We can think lots of examples. So why it's important? Okay. So since this is a
Buying a, winning the lottery ticket without buying a ticket.
yeah, correct, correct. So that is different. So okay, let me try to explain why. Suppose you have any different like impossible event or null event and all, then probability for that event will be 0. Okay. So why this is important? Basically, if suppose I'm saying this will help you when suppose you have two event E and F. Okay, or you can say let's say you have event A and B, something like that, and intersection of E and F. Intersection normally we are denoting E intersection F. If you are getting intersection of these two events as a phi, I mean suppose there are two events and intersection of those two you are getting as a phi. Okay, then we will say this E and
Mutually
F.
disjoint.
Okay, this E and F are mutually exclusive. Okay,
Disjoint.
mutually exclusive, or you will say disjoint even. Okay, suppose for example, so this is the okay. So this phi means this contain nothing. Okay, so okay, before that, everyone is aware about this union intersection part, right?
Yes, sir.
Yes,
Should
sir.
I?
Yes, sir.
It's a theory.
Yes, sir.
Theory part is okay,
Set
right?
set theory. Yeah.
Correct, correct. So
Set
union
theorem.
means it will include yeah, let me come to that point. Okay, so maybe it will be clear. Okay, so what is the meaning of intersection? Basically, suppose you are doing experiment,
Common to both of them.
Common point, sir.
yeah,
Yeah, sir.
suppose you are doing rolling a die. Okay, then possible outcomes will be 1 2 3 4 5 6. Okay, suppose I'm defining event T as odd numbers. Okay, then what will the possible outcomes for this? 1
3
3
and
1, 3,
1, 3,
and
5.
5.
Suppose I'm defining F as a even numbers.
2, 4, 6.
2, 3, 4, 6.
2, 4,
2, 4,
6.
If I will say E intersection F, so is there anything which is
No.
common between E and F?
No.
No.
Nothing.
That
No,
is
sir.
phi. That is you can say blank. Correct?
Blank.
Okay.
So, sir, the
Sir, phi
probability
is
will be
not.
0.
Sorry.
The probability will be 0, right?
Probability will be 0. I will come to that point. Okay. So this
Okay.
is meaning of intersection. Basically, we are saying we need to check common things. Okay. So what is the meaning of union? Suppose E is again. Let's say I have E as a 1 3. Let's say E1 and E2 event as a 2 comma 4. Then union means E1 union E2. It will be 1 2
2, 3, and 4.
4. Okay, or else suppose you have event A as a 1 2 3 and B is a 3 4 5. Okay, then A union B will be 1 2
1, 2, 3,
3, 4,
4,
and
5.
5.
Okay, okay, so far so good, fine. So these are something we know. Okay, now I will come to part. I will come to the part called Venn diagram. Okay, before that, let me try to explain something to all of you. Okay, so yeah, Venn diagram. Okay, so basically there is something called complement. Okay, complement of a of an event. Okay. Suppose what is the complement? So let's say I'm saying S sample space is 1, 2, 3, 4, 5, 6. Okay. So if I will say, suppose I have event E odd number, let's say 1, 3, 5. Okay. So complement we are denoting with E complement. So what will be the E complement? Which is
2, 2, 4, 6.
basically I can say S minus E, right?
Yes, sir.
Basically 2, 4, 6. Okay. So sample space, normally I will come to the Venn diagram part. So sample space we are denoting, suppose this is your total sample space. Okay. You have two events, let's say A, and let's say this is B. Okay. This is A, this is B. So what is the A union B? So A union B means this whole part. Yes or no?
Yes, sir.
Yes, sir.
Yes.
Correct.
Yes, sir.
And what is the A intersection B?
The middle one, sir.
Common,
This
common.
red
Common
part.
part, sir. Yes, sir.
Correct.
sir.
Yes,
So
sir.
this red part will represent A intersection B, right? And
Yes, sir.
this whole thing is S. Okay. Suppose okay, so this is S and this is A. This one is B. Okay. Suppose this is the A, this is the B. What if A? If I will ask A complement, A complement is what? Except A. That means
B
this all
part.
things, not only B
Sir,
part. I'm
not
talking about
Except A,
the A
sir.
part, sir. A part, the
Just we don't have
Except
to
the A
include.
circle.
delete the intersection part. Yeah.
yeah. So you can see the black shaded region, right? So this will be as A complement, right?
Yeah.
Yes.
Even sir, intersection points also be like through it out intersection point also as
Yeah,
well.
intersection I haven't included.
Yeah.
Okay. Now, so what if I will say, suppose this is B, this is A, this is sample space. What if B complement except
Sir,
B?
sir, we are deleting B from
Yes,
this
sir.
whole
Yeah, leaving the
thing.
B.
Correct.
Yes,
Except
sir.
B means this blue shaded region.
Yes,
Yes,
sir.
sir.
Yes, sir.
Correct. Now let's do some other things. So maybe that will give us more idea. Suppose this is A, this is B. Okay, and this is your whole sample space. What if I will ask you, tell me, A union B comp. It will take some time. Just think a bit.
Sir, S
The
minus
part
A
which is
union B.
outside
Sir,
circle.
it is
Okay.
opposite of intersection,
Outside
sir.
circle.
A intersection
First,
B, sir.
okay, first see what is the B complement. So B complement will be what? This red region.
Yes, sir.
Okay. So basically we can think a little bit. So this is the B complement.
S
Correct?
minus B.
Yes, sir.
And what is
Yes.
the A? A
A
will be
complement opposite, sir.
That circle
this
part.
this green region.
Green region, yes, sir.
Okay. And what is the union of these two?
A intersection.
The
Sir,
whole part.
all parts, sir.
Cut the intersection
A
part.
circle and B
A
circle.
intersection B.
No, whether we have to
Only
include
A.
A union B minus B.
yeah, that is the numerical thing. Why I'm talking about. My question is with this region. So can I say this part, right? This, let me add two. So this, I mean, including red and green. Yes or no? Right?
A
Including red and green.
minus A intersection B.
Can I say this part? This blue one is this will represent A union B complement. Yes or no?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So S minus B.
Suppose I'm saying another thing. Let's say this is A, this one is B. Okay. What about A union B whole complement?
Deleting A union B and
Okay.
just
So A union will
The
be
deleted part.
Then the
deleted.
circle part.
The outside
Yes, sir.
part.
No,
Outside
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 part.
part.
correct. So this black shaded is the A union B, right?
Yes,
Yes,
sir.
sir.
Yes,
If I will A union B whole complement means this outside part.
Yes,
Now,
sir.
Yes.
correct. So now one interesting thing you will find in a minute. So what about A complement intersection B complement. Suppose this is
Sir,
A.
it is opposite of that section, the diagram, the
Okay.
above diagram, sir.
Okay, so I'm talking about A complement intersection B complement. First of all, let's try to find what is the A complement. A complement is this part,
Yes,
this
sir, all
black
the part.
shaded,
Yes,
Yeah,
sir.
right?
except A
And
plus
what is the B complement? B complement will be this,
B part.
B part.
this blue part.
Yes,
Yes,
sir.
sir.
Okay. So I'm
The
talking about common. So
yes,
common will
sir.
be what?
Common
Same
will
as
be
A union B
intersection, sir.
complement.
A intersection B.
A intersection B, sir.
Outside part.
Say, okay, so common is what? This blue, yellow one?
Yes, sir.
Yes or no?
Same as A union B
Yeah.
Correct.
complement.
This is the same as this part. So you can simply say A union B whole complement is same as A complement intersection B complement. Yes or no?
Yes,
Okay.
sir.
So these kind of things is very
Yes,
helpful
sir.
whenever you will solve, some problems, related
De
to
Morgan
when
theorem.
De Morgan's theorem. This is called De Morgan's theorem. Once we will move, independent events and all. Okay. Suppose, this part is given to you, complement part is given to you, and you have been asked union part, then you can directly use these kind of things. Okay. So similarly, you can try, so I'm giving you as a exercise, you can try this one. So with the same pattern, actually, you can try. I mean, you can verify itself. This A intersection B whole complement. This should be equal to what? A complement union
Union B.
B complement.
B
Okay.
complement.
Okay. You can verify this part. Okay. With the same property. Okay. Now I'm moving ahead because it's all about 9. Okay. So we'll see something about more on our content of week
Sir,
10.
if there are infinitely many outcomes,
Yeah, we saw, for a bulb example. Okay. So
if
according
there are
this,
so how will we like define the sample? How will we define the sample
that is something
space
we
in that
see we,
case?
okay, okay. For those kind of thing, I think we can,
Sir, all real number.
yeah, basically whenever see we'll see this, your experiment is it belongs to, real up to or R or no R3 and all. Okay. So that is visualization is
Yeah,
we said tough. Yeah. Okay. So as of now we are focusing now. So I will move to this part, probability, something called probability axioms. Okay. So what is the probability? There are some axioms. So before probability axioms, I will, okay. So there are some, 2 to 3 definitions of some, formal definition of probability called, classical or a priori probability. And, then you will say some statistical or empirical probability. No, so those kind of things. I'm not going to that. I'm just, you can watch on the lecture video. Then say, you can consider as a homework or something like that. I will basically focus on a basic definition of probability. What is that? So probability, basic definition of probability is how we can compute probability. So probability for any event. I mean, suppose you want to calculate the probability of occurrence of event A. So this is nothing but favorable cases. Okay. So number of favorable cases divided by total number of cases. So this is something we can compute the probability. We will see. So there are some some axioms related to this probability. How we can, I mean, what are the basic, you can say assumptions or something like that. So first one is for any event E. Okay. So this probability will always be like between 0 and 1. Okay. Second one is probability of a sample space is always 1. So probability of a S I'm writing as a 1. Okay. So basically why this probability of sample space is 1 I will show you in a minute. And third axiom is, if suppose you have a sequence of or set of mutually exclusive events. Okay, for a sequence of. So what is the meaning of mutually exclusive? This is same as saying disjoint event, right?
Yes, sir.
Okay. So for these kind of things, so I will say like I have said like E1, E2 and so on. Okay. So probability of union of all these EI will be same as summation of I is equal to, let's say, 1 to infinity. Infinity means there are lots of, we don't know whether it's exactly n or n plus 1 or something like that. It will be probability of EI. Okay, so I will give you the idea behind this in a minute. Okay, so we have to keep in mind these things. Okay, so probability will always be lie between 0 and 1. Some probability of a sample space will always be equal to 1, and for a sequence of mutually exclusive disjoint event, this is the case. Okay, what is the meaning of this? Suppose you have two events, let's say E1 and E2. So probability of E1 union E2 will be same as probability of E1 plus probability of E2. I will come to this point in a minute. Before that, let me explain you some basic thing of probability. Now, suppose I take example of tossing a coin. Okay. So what will the sample space? H comma T, right? Suppose this is fair coin, means there is not any manipulation or some biasness we have done. So what is the probability of getting hit?
1 by 2.
1
Okay.
by
So
2.
basically, what is the definition? Favorable cases
Upon total
divided by
number of outcomes.
Divided by
total cases, right?
Total
yes,
cases.
sir.
Total
Total
cases is
number
what here?
of cases.
2, sir.
Total cases is 2.
2.
What is the favorable case in which
1,
you are
sir.
interested?
Either
So
we
I'm
can get
interested
head
in here. So
1.
head. What about probability of T?
1 by 2.
1 by 2.
1 by 2.
Now, suppose I have asked your experiment
Throwing a dice.
throwing a die. Okay, and I ask suppose S will be what?
1
1,
by 6.
2, 3, 4, 5, 6. Okay.
Yes,
Suppose
sir.
I ask what is the probability of getting 1?
1 by 6, sir.
1 by 6.
1
1
by
by
What
6.
is the
6, sir.
total case? Total case is 6. So
6.
whenever you are going to solve questions related to probability, right? First find the total number of total case, okay? And then what is the favorable? Favorable is 1. Okay,
Sir, I
suppose
have
I'm
a
defining probability of, getting more than 3. What about
1
this?
by 2.
Sir, 3 by 2, 3 by
1
6.
by
by
2.
1 by 2.
1 by 2, sir.
1 by
Okay,
2,
forget
sir.
about 1.
1 by
So
2.
what is the total?
6.
3. 6.
6,
Hmm.
right? What about favorable
3,
case?
3, sir.
3, sir.
Okay,
3.
more than 3 is 4, 5.
6.
So this will be 1 by.
1 by 2.
2.
Okay. Now, let me take something, some other example. Let's say I'm saying I'm throwing, two unbiased dice. Okay. If you're throwing two unbiased dice, okay, then what will the possible outcomes? Tell me.
6 by 12.
6 by, no. Uh-uh. I'm asking
36.
about possible outcome with
36.
sample space.
36.
Oh, 36, sir.
36.
36.
This is
Okay,
36.
36. Because outcomes can be 1 comma 1,
Yes, sir.
1
Yeah.
2,
36.
1 3,
1, 3, 1,
1
4,
4,
1, 5, 1,
1
6.
5, 1 6, right?
Yes, sir.
Similarly, 2 1,
2, 1,
2
2,
2,
2, 2,
2
3,
3,
2, 4,
2 4,
2, 5, 2, 6.
correct? 2
Yes, sir.
6. Okay. Similarly, 3 1
3,
2,
1, 3, 3, 2.
3
Yeah,
6,
3,
right?
6. Yes.
Similarly, 4 1 2,
5 1
4,
6.
6.
4 6, right?
5
5
1.
1 5
5
2 up
6.
to
5, 6.
5 6.
6
Okay.
1.
And 6,
6
1,
1.
2, 6, 6.
Okay. So now what is the total number of cases here?
36.
So total cases is here 36, right?
Yes, sir.
Now, so what is the probability? I told you probability is what? Favorable case divided by total case for
Total
that
case.
particular event. Okay. So what if I will ask probability of, let's say I'm saying E. Okay. E is what? Let's say E1. E1 is what? Both the dice show the same number. Okay. So what will the probability of E1? So first of all, see, whenever this
1
is
by
question, right?
6.
First see
6
what
by
is the total.
36.
So we'll see
6
what
by
is the
6 by
total
36.
case. Yeah, one by
By
one.
6.
Yeah. This is the total case, and this is the favorable case, right? Now, what is the favorable case? How many both dice show the same number means what? This will be 1 1, 2 2,
2 2
3 3
3
3
3,
3
4
4
4
4
4
and
4,
5 5 6
5
6
5
5 5.
6 6.
So this
So
is
6 by
something
36.
meaning of both the dice show the same number, right? So this is
Yes,
the
sir.
6. What is the total case?
36.
sir. 1
This
by
is
6.
1 by 6. Now, everyone has pen and paper. Okay?
Yes, sir.
Okay. Now, I'm just writing something. You can tell me the answer. So suppose the first die shows 6. Okay, what will be the possible outcomes? Like, what do you mean by this first die shows 6?
There are 6 outcomes.
We have to
6
check
outcomes.
the outcomes
7
in
by
which there are in first time they
6
appear
comma 1, 6
6.
comma 2, 6 comma
Yes,
3
sir.
up to 6 comma
Correct,
6.
correct. So I mean, what is the favorable cases? So
6
favorable
6 by
cases are
36.
6
so
by 36.
so
6
this means
out of
6 comma 1,
36.
right?
6 comma 2.
Yes,
6
sir.
6
comma 2,
comma
6
2,
comma 3,
6
6
3
comma up to 6.
6, 4,
correct,
6,
6
5.
comma 4, 6 comma 5, 6 comma 6.
correct. So this is meaning of first die shows the 6, right? And you know
Yes,
what
sir.
is the total cases? So probability of E2 will be favorable cases 6, total case is 36, which is
1
again
by
1 by
6.
6.
1
All
by
right.
6.
Now, what if I will ask, suppose E3 is, you can say a total of the numbers. Let me change the scenario. The total of the numbers, okay, on the dice is 8. So what will the favorable cases when total should be, 8?
2
It
6.
can
4
be,
comma 4,
Sir,
6
2
comma
6
2,
sir.
2 comma
2
6,
2
2
comma
6,
6
6 2, 4 4.
yeah, okay,
1 comma
let's from
7.
start. 2 6,
2 6. Yes, sir.
3 5,
3
3 5,
5
4
4
4,
4,
4 4
5 3,
and 5 3
5 3,
6
6
2,
2.
and
6
6
That's all,
2.
right?
Yes, sir. Yes,
Yes,
sir.
sir.
So what will be the
Yes, sir.
probability of E3?
Sir, 5 by
5
36.
by
5 by,
36.
okay, very good. Now, suppose I'm saying E4, total of the numbers,
Sum of the number. Yes.
yeah, total of the numbers on the dice, let's say is, initially we took 8, right? Okay, let's say greater than 8. Okay, so greater than 8. So what will the favorable cases? Greater than 8, that
4
means what?
comma 5,
3 6.
4 comma
3
5,
6, sir.
Yeah, so whenever this
4
is the
5,
case, right?
6
Okay,
4
so
5.
this is a suggestion. Just start from beginning. If you start from in between, you will get confused which cases you included. So 3 6. Okay, then I can say
4
6
5,
3.
4 5
4
Yeah,
5
4
sir,
6 5
4
4
5,
5
5
5
4,
5
5
4.
4,
Very good.
Sir,
5
Then
4 by
5 5,
36.
6
5
3
5.
5 5 6 6,
4 6,
4 6.
6
6
4.
6,
Yeah, 5
5,
5,
5 5 6 6.
6
sir.
6
5 6. Yeah, 6
6
5
6
and
6 5
6. How many cases?
Sir, 10 by 36, sir.
10
5
by
by
36.
18.
Okay, so
Yes, sir.
probability of E4 is favorable cases. Favorable cases 10 divided
Yes,
by
sir.
number of total cases, so 10 by 36.
5 by
Okay,
18.
now okay, now next case, suppose I'm asking the total of the numbers, okay, you will tell me whether it's correct or not. Suppose, what will the answer for this? The total of the numbers on the dice is 13. What will the probability
0.
for this?
Mm,
Zero.
There is nothing.
0.
0.
0, right? So
0.
this is what? Impossible event, right?
Yes,
Yes,
sir.
sir. Null.
Null
Sir,
event.
null event, sir.
Yeah.
Null event.
And we know what is the probability for impossible event? It's a
0.
0.
Okay, you can think
0.
like this. What in terms of probability? So probability is what? Favorable cases divided by total number of cases. So total number of cases is 36. But for this, there is 0 cases, right? It will be. Do you agree with
0.
me?
0.
Right? Now, suppose I'm saying total of the numbers on the dice is any number from 2 to 12 and both inclusive, then
It's 1.
it's a
Sir, 1, 3, 1, 4, 1, 5.
no, from 2 to 12 inclusive. Sorry, both inclusive means, see, I'm
Okay,
talking
2
about
also.
1, 1, 2 till
1
6,
1.
6.
It's
6,
whole
6.
sample space.
See, I'm including, yeah,
Oh,
so I'm
in that
including
case, sir,
whole
so whole
sample.
samples, yeah.
So probability of this will be either
1.
36
1.
divided by 36 as a
36, 1.
1.
So we can see probability of a sample space is always 1 and
Sir,
probability of an impossible event it will always
sir, I
be
didn't understand the inclusive, sir.
0.
inclusive means I mean including
2
2
and
and
12
12
are
also.
included.
Like everything is included.
Correct,
Yeah.
correct. If I will say let's say
Smaller than equals to and greater than
correct.
equals to.
Suppose I'm talking about 2 to 12 between 2 to 12, let's say something this event is 6 is 2 to 12, that means I'm excluding 1 1 and 6 6. Okay, what will the probability for this now this case?
Sir,
This is
it
the
should be, sir, it should be
34
greater
by
than equal to,
36.
sir. Sir, it should be greater than equals to.
No,
Yeah,
no.
You have only given symbol.
No, I'm saying
34
suppose
divided
it's
by
more than 12
36.
and I'm saying, yeah, more than 2 and less than 12. That means I'm excluding
Oh,
1
okay.
1 and 6 6. That means I'm talking
34 by
about
36, sir.
correct.
3 to 11. Yeah.
So some
So,
sort
sir,
of rough
this is the
idea is
answer,
okay.
sir.
Yeah, this is the answer.
Okay, sir.
Some sort of
Sir,
rough idea is okay to all of you.
sir, what was the one answer like 36 by 36?
See, in that case, I'm including all. See, I'm say I told you some should be from 2 to 12. Right. So minimum is 2. It will start 2, 3, 4, something like that till 12. So 6 plus 6 will be 12. So I'm including all the cases. So for everything, it will be 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. Okay, sorry. 1 by 36, 1 by 36 plus 1 by 36 plus 1 by 36 up to 36 times it will be, right? So it will be 1 by 36, 1 by 36, 36 times. Basically, I'm talking about like this for each cases. So you will get 36 divided by 36, which
Yes,
is
sir. 1.
okay. Let's talk about in very simple example. Suppose I'm saying you throw a die only once, then you'll get 1 2 3 4 and 5 and 6. Okay, what if I will ask tell me the probability of all the numbers? I mean, I'm getting all the numbers 1 2 3.
6
I
by
mean
6.
at least one.
1.
So what will be
1.
case? So I will say, yeah, 1 by 6 plus
Yes,
1
sir.
by 6 plus 1 by
Yes,
6.
sir.
By 6, sir.
6 by 6.
Okay, so it's just 6 by 6,
1.
which is 1. So we know we saw probability of S will be 1, probability of a null event is
0.
0, and probability will always be lie between 0 and
1.
1. Okay, so let me take another example, maybe that will give you some clear idea. Let's say everyone is aware about card parts, like how many,
Ace, spade,
Yes.
jack,
ace,
Yes, sir.
king,
spades,
queen.
and all are there.
Yes, spade, diamond,
Mm.
hearted.
Club, yes.
Joker as well.
Diamond.
Okay.
Total 52.
Club,
Okay, let me
diamond,
tell you. So there is
Set of
Sorry, hearts,
13
it's
na,
bridge,
in
bridge.
52.
okay. Let me tell you. There is something called pack of cards. This is very interesting part in whenever you will
Deck of
read.
cards.
Yes.
Yeah,
Yeah.
take up cards. Whenever you will, going to learn probability. These are the examples. Very important.
52.
So in this pack of cards, there are 4 suits. Those 4 suits called, first one called spades.
Spades, yes, sir.
Okay.
13.
Then
Club,
Sir, it's diamond, then
hearts. Yeah.
hearts,
diamond, and
diamond,
club.
club,
13 cards each.
Diamonds and
and clubs.
clubs. So this is the collection of 52
52
cards.
cards.
And in spades there are 13, 13,
13, 13, 13.
13 and 13. Okay. So also so in each this this, let me write like this. Maybe that will be very easy to understand. So this is the clubs.
And sir, each suit contain king, queen,
This is hearts. This is the
diamond.
diamonds. Okay. Each suit contain basically, these 13 number, 13 cards. So in that 13 cards, there are 9 cards. Okay. Those are numbered from 2 to 10.
10.
Okay. And there is an called ace, a king,
Jack.
a queen, and a jack.
Jack.
So 9 cards from here, 10,
These
11,
are called
12,
face cards.
13. So these, these are called face cards. This ace, king, uh, uh, queen, and jack. Okay, actually one more thing, this part, right? So you can see this spades and clubs all are black face cards. That's why I wrote in black. So these are black face card. Okay. If suppose I will ask, tell me the number of total black face cards, so you will tell me 26.
26.
Right? Ask, red face card. So hearts and
26.
diamonds are red face card. Okay. Okay. Some sort of idea is clear to all of you?
Yes, sir.
Yes, sir.
Regarding cards. Okay. Let's try to do one question related to this. Then we'll move
Sir, I
another
have a
part.
doubt, sir.
Yes.
Sir, is ace also included in face cards?
Ace,
Ace.
queen.
You recently told us that these 4 are the face card. That's the reason you
Sir, king, queen, and jack are only face cards.
But ace is not
Yeah,
there.
yeah.
Yeah, ace is not, I think.
Yes, is not there. Right.
Yeah, actually, total, 12 cards are the face card, if I'm not wrong. Correct me, right? Yes or no, right?
Yes,
Total
sir. Yes,
12,
sir.
Yes,
12
sir.
are the face card, right? Yeah.
Yes, sir.
Yeah, sorry about. So ace is not a face card. This king, queen, jack are face card. So let's start with a problem. Maybe. So suppose problem says, let's write as example. Okay. So suppose what I'm going to tell you. Suppose case is, suppose I'm going to draw 4 cards. I mean 4 cards are drawn at random from a pack of. Okay, tell me. Suppose I'm saying drawing a card from a pack of 52 cards. So is it random experiment or deterministic experiment?
Random experiment.
Sir,
Sir.
random.
Random
Random experiment. Okay. Okay, great. So you have to find the probability first. Okay. Right. Find the probability. Okay. I will write some scenario. Okay. We have to think. So first one, let's say they are a king. Okay. And okay, before going to king, queen, and all. Okay, let's do before. Let's say there are a king, a queen, a jack, and an ace. So what I told you about, probability. So for probability, what we need? Favorable cases, number of favorable cases, yes or no?
Yes,
Divide
sir.
by
Yes, sir.
total number of
Yes.
cases, right?
Total.
Yes, sir.
Yes, sir.
So for this, tell me what is the total number of cases? Let's say I'm denoting as E1.
52.
52.
52.
52 C4.
No. For this part, just
52
think.
C4.
Correct.
60.
No.
52
I'm talking
C4.
about C. Total cases. See, if I'm going to
16 divided by 52.
1 second. If I'm going to throw dice twice, that means how many outcomes I will get? 36, right? Total 36 is possible, right? So here, what is the experiment here? So 4 cards are drawn. So what if it is the total number of cases? You can draw 4 cards.
52 C4.
Correct. So
52
52
C4,
C4, right? These are the total number of cases. I can draw 4 cards. Yes or no?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
what is the next case? What is the favorable case? I'm talking about a king, a queen, a jack, and an ace. So there are how many kings? A king here for spade, a
Four
king
kings.
for
Sir, four
club, a
kings,
queen
sir.
for hearts. Correct.
Four
12
Four
kings, sir.
king, right?
Yes, sir.
Correct.
Sir,
Total,
4 king or
I
4,
will be
12
having
king.
4 kings,
4 for 16, sir. 16.
4 queens, right? 4
Yes, sir.
jacks
Yes, sir.
and 4
Ace.
ace. Right? So now I talked about a king, a queen, a jack, and an S. Then in how many ways I can select one king?
4C1.
4C1.
In how many ways I
Four,
can a
4C.
queen,
4C1.
4C1.
a jack,
4C1, C.
a
4C1.
NS?
Yes, sir.
4C1.
4C1.
So what will the probability for this?
16C4, sir.
So probability will be
16.
4 into 4 into 4 into 4. This is the favorable number of cases divided by total is 52.
52.
Yeah.
Yes,
So here
sir.
why we took C, because we have to choose and we are not worrying about order, right? We didn't say first should be king, then queen, something like that. Okay. What if in the same scenario I will ask 2 kings and 1 queen and 1 ace? Then what will the probability?
4C2, 4C1.
4C.
Correct.
Oh, yeah.
4C1 into
4C1
4C1.
upon
4C1.
52C4.
52 by C.
Correct. 52C4. Very good. Now, if I will ask, let's say I'm defining E2 as 2 are kings. 1 second. Okay, let's say 2 are kings and 2 are queens.
4
Then,
by
4C2
52.
into
okay.
4C2.
No, forget about like this. Just tell me what is the total number of cases? 52C4, right? And we know there are total 4 kings. In how many ways I can select 2 kings?
4C2.
4C2 and
4C2 into
4C2.
4C2.
So whatever the calculation, you will get the final answer, right? Suppose I'm going to change the scenario. Let's say I'm talking about 2 are black and 2 are red. So you can see how many black cards are there. Total black cards. I'm talking about
Sir, 26, sir.
26, right?
26, sir.
And
26.
26 red, right?
Yes, sir.
Yes.
So that like black can be anything, any black, right?
Yeah.
So probability of E3. First of all, let's write total. Total is 52C4. So black for
Sir,
26C2
26C2, sir.
26C2.
for red.
26C2.
Sir, 26 to C2.
26 and C2.
Right? You are getting the idea, right? How we are proceeding with this.
Yes,
sir.
Yes, sir. Yes,
So
sir.
let me change the scenario a bit again. Suppose I'm saying there are two cards of, you can say, from hearts, and let's say 2 cards from diamonds. Okay. Then what? So we know what is the total number of cases?
13C2,
52
52C2,
is the
4.
total case, right?
Yes,
Yes,
sir.
sir.
And what is the total number of cards with the heart?
Sir,
We know
13.
13. For diamond, 13.
13.
Right?
Sir,
So
13C2
favorable is
into 13C2.
correct. So you can say, you can see here, we in total we are selecting 4. Here 2, here 2. It will include all 4. Correct?
Yes, sir.
Okay. So now I think okay, let me suppose I will ask all 4 cards, something like that. Suppose I mean I'm talking about 4 cards, so I can say, suppose cards from each suit. Then there are 4 suits, right? Spades, clubs, correct?
Diamond. Yes.
So
Yes,
cards
sir.
from each suit means what? So there are total
13
4,
C.
correct? So and at the end we are selecting 5. Sorry,
4.
4, right?
Yes.
So that means what I'm talking about.
13C1.
One from
13C1.
space, yeah.
Yes.
One from
13C1.
club, one from heart, and
Heart,
one from.
one or heart dynamo.
Okay. So
Yes,
final
sir.
answer can be any. Okay.
Sir, can you solve 13C1?
Yeah, 13C1 is
13C1 is
13.
13.
You have to apply formula. I'm not going to apply this formula. Okay. It's
N
anyway
factorial,
you have
n
done in
factorial
week.
divided by n minus
Yeah,
r factorial.
it's
Yeah,
Yeah.
sir. I
And
was
r.
just
Permutation formula.
Yes.
yeah. So it's a permutation combination formula, right? So this is
Yeah,
very
sir.
basic thing. Okay, so there is something. So okay, I told you, right? Complement part, right? Okay, like what is the A complement? This is S minus A, something like that. Yes or no? Okay.
Yes, sir.
So what is the probability of A complement? So probability of S minus probability of A, you can simply say, so 1 minus probability of A.
A union.
Yes, sir.
Basically, what is happening? A union A complement will make S, right?
Yes.
Yes.
Yes or no? Suppose this
yes,
is
sir.
Yes.
S, this is A, this will become A complement, right? And
Yes.
including these two will become S. So probability of A union A complement is S, right? And you know A union A complement is what? Both are disjoint. So I will write probability of A plus probability of A complement plus equal to probability of S. So what will be
Yes.
probability of A complement? Probability of S minus probability
Minus
of A.
probability A.
Forget about this. This is not a correct way to do this. Okay? Just try to understand. So 1 minus probability of A. Right? So this is something you can define like when you will talk about some mathematical things. Suppose, for example, what I mean by this. Suppose I will say something probability of, at least one. At least one. At least one means what? Can I do, 1 minus probability of none?
Yes.
Yes or no?
Yes,
Suppose
sir.
I'm saying there is a x is taking value at least 1, means x is
1.
greater or equal to 1. I will
Yes.
say 1 minus probability of that complement x is taking 0. Yes or no?
Yes, sir.
So if there is something you have been asked question related to probability of none, right? Then sorry, probability of at least 1. Then it's easy to find 1 minus probability of none. Why? Because in case of none, you have to consider only one case. While in this case, you have to consider all the case x equal to 1 plus probability of x equal to 2 plus probability for x equal to 3 plus so on so on. Yes or no?
Yes, sir.
Yes, sir.
Okay. So like we can okay. So okay, let me change take you another example. Suppose I'm saying there is a committee of, after that I will take one. Suppose there is a committee of, let's say 4 persons is to be appointed from, okay, everyone has pen and paper, right?
Yes, sir.
Yes, sir.
Okay. Yeah. So I will ask this question. Let's say they are from production department. 3 are from, and 4 of the, you can say some, let's say purchase department. Again I'm saying let's say 2 executives of the marketing department. Okay. And let's say one is CA, like uh, chartered accountant. Okay. So what is the question? You have to find the probability of, for what? Forming the committee. Okay. In following manner. Okay, so I'm going to give you some scenario. So, okay, question is clear to all of you, right? So you have to form a committee of 4 person, right? From 3 executive of production, 4 executive of purchase, 2 executive of the marketing, and 1 from chartered account. So what is the total number of people?
The
Yes.
person is four, sir, actually, and department is four
10.
department.
Total are 10.
No, I'm okay.
10.
Okay, question is clear or not? See, you have to
Yes.
create a form a committee of 4 people. From where? From 3 are
10,
from
sir.
production. Yeah, 4 are from purchase and 2 are from marketing, 1 from chartered account. So 10. So what is the total number of ways you can select person?
So 10C4.
Correct.
Yes, sir.
That's what.
10C4.
10C4 is clear to all of you?
Yes, sir.
Now,
Yes, sir.
Yes, sir.
question is, I will give you 2 minutes. I don't want the final answer. That's why I'm saying there must be. I just wanted to. You should be clear with the state. There must be 1 from each category. Okay. What should I write?
3C1,
Sir, total
C1 into 3.
1C1, 2C1,
Yes.
1C1.
So 10C4.
2C1,
So
1C1.
2C1, yeah.
So 1 from each category. That means what? So first of all, total number of cases what?
10.
10.
Sir,
I'm
10C4.
talking about
10C4.
yeah, 10C4, right? And
Yes, sir.
1
Yes,
from
sir.
each category means there are 4 from
20.
4C1, sir.
3C.
4C1, sir.
favorable cases will be 4C1
Yes,
into
sir. 4C1.
3C1 into
3C1.
2C1 into
3C1 and
1C1.
2C1, yeah.
2C1, 1C1.
Yes, sir.
Correct.
Yes,
This
sir.
is your
Divided,
favorable cases, right?
yeah.
So what will the probability for this? So it will be 4 into
4C.
3 into 2
Into
divided by
24.
10C4.
10.
4.
Yes, sir.
Is it clear?
Yes, sir. Yes,
Now,
sir.
suppose second part I'm saying,
4
probability
factorial.
you have to form a category committee such that it should have at least 1 from the purchase department. If I'm saying like this, so what you have to do? You have to, I mean, that candidate should be at least 1 from purchase department means what? You can do in 2 ways.
Sir, it should be more than, sir,
4C1.
it is more, it should be more than, sir, 1.
Correct. So how many people are in purchase department? 4, right?
4, sir.
4C1
Okay.
into
Correct. So in how? Okay,
6
there are
C3.
3 from what departments?
Sir, purchase department.
4 from
Four,
purchase. 4, 4.
four from
3
purchase.
were from production.
Production, yeah.
Okay.
Hmm.
4 from purchase. Okay.
2
from
marketing. 1 CA.
1 for
1
CA.
CA. Now, so question is at least 1 from purchase department means what? So what is the meaning? So that means, can I say something like this? Okay, so I told you, right? Probability that at least 1 from purchase, can I say equal to 1 minus probability none from purchase?
Yes, sir, we can say.
Yes.
Yes, sir.
Can I say? Because this part is complement of this part. Yes or no? So none
Yes.
from purchase means what? 1 minus, that means all 4 are from, others part, right?
64.
So
Yes, sir.
basically what we have to do, total is 10C4.
Yes,
Basically
sir.
we have to select 3, 2, 5, 1, 6, right? So we have to select 4 from these 6. Yes or no?
Yes, sir.
Yes, sir.
7C4.
64.
64.
64.
Okay. And what you can do in, so this is one way, it will give you answer. So another way is if you see at least, 1 from purchase department. So that means what? It will be
4C1 plus 4C2 plus 4C3.
we have to do 4C1 into what about remaining? Remaining is 6. So that means 1 from purchase and remaining 3 should be out of remaining 3 department.
Yes.
Yes,
Yes,
or no?
sir.
Divided by 10C4. Yes.
Yes, sir.
So here
Yes, sir.
I have selected 1 plus. See, it is talking about at least 1. That means 2 can be there also.
Yes, sir.
3
So
can be there
Three
also.
can I
can be
write? I
there.
can write 4C2 into 6C2
63.
divided by
Yes,
10C4
sir. 10
Yes.
C4.
Yes.
plus
Mm.
4C3
So there
into
will be 4
6
6C1.
cases.
C1.
6 C1,
Correct. Then all are from.
4 C4.
Okay.
Yes,
So
sir.
what you can do, you can check answer from this and answer from this. You will get the same. Is it okay? Is this clear, right? How we are doing? Yes or no?
Yes, sir.
Yes.
Okay. Now, if I will ask charted account, now you will tell me. I'm not going to give the answer for this case. No, chartered account. I mean, this accountant, you know, must be in the committee. How should I proceed? Yeah, tell me.
1 C1
Sir,
into
for 1 C1, sir, 1 C1 should be
1
confirmed, sir, because we have to take the chartered accountant, and rest of
into
the
9
three,
C3.
and rest of the three will be taken from that 9 C3, sir.
Correct. So
Yeah.
we know CA is already in the committee, right?
Yes, sir.
That means I have to choose
1
like you
C1,
know
sir.
3 people from the 9, right? Divided by
Yes.
10 C4. Yes or no?
Yes,
This
sir.
one
Yes,
is
sir.
fixed, right? Okay. Or else you can
Yes,
do
sir.
like this 1 C1. I mean, anyway, you will get the same answer, but
Yes, sir.
okay. Is it
Yes, sir.
clear?
Yes.
Yes, sir.
Okay. So now I'm going to take
Sir, we can do
again.
it by 1 minus 9C4 upon 10C4.
Yes, sir. The narrative
Uh,
approach.
ah, yeah. The similar to this question, I'm going to write example. Okay. Suppose there is a box. A box contains. Okay, maybe after this you will get more idea. 6 white, 4 red, and 9 black balls. Okay. Question is, if 3 balls are drawn, at random, so you have to find the probability that, okay, first is, don't tell me the answer now. I will write some 2 to 3 scenarios, and then I will give you some 2 minutes break, and you can suppose all 2 of the balls are white, and okay, just think about this. Okay, I will be I will give you 1 minute, okay, and I will be back in 1 minute. Okay, you got the answer?
Yes, sir. Yes, sir.
Okay. So first of all, tell me, what is the total number of cases?
19 C3.
19 C3.
Okay. So why we are doing 19C3 and not 19P3? Because we are not worrying about order, right?
Yes, sir.
Okay, now what about this favorable cases?
Sir, 6C2, sir.
Correct. So we are interested in two balls are
From
from white. So
white.
that means there are 6 white. So there's I have to choose out of 6, but in total we have to draw 3. So that one ball it can be from this 13, right? 9 plus 4. Because okay, there is no
13.
condition, right? It's so it will be 9C1. Okay. So what will be the probability? Probability
So,
will
sir,
be
13C1.
Sir,
Yes, sir, 13C1.
correct.
Sir,
Yeah,
13C1 it will be.
yeah, correct. Yeah. So it will be probability will be 6C2 into 13C1 divided by 19C.
19C3.
Now let me change the scenario. Suppose I'm saying one ball is of each color. Then there are 6 white, okay, 4 red, 9 black. So what will the probability?
61 to
61,
4C1 into
4C1, 9C1 divided by
Correct. So divide by 19C3 is the total, and we are drawing one ball from each. So
6C1,
6C1,
4C1,
4C1,
9C1.
correct? Very good.
Yes, sir.
Suppose I'm saying none is red. That means what? Okay, what is the meaning of none is red?
No red ball.
All
No red ball.
that is red.
That means we are drawing all 13 balls from 6 white and black.
Yes.
Yes, sir.
So what will be the favorable case?
15C.
15C.
15C,
15C3. Correct?
Yes, sir.
Okay. Suppose I'm saying, at least one is white. At least one is white. That means what? So
More
probability
than
of
one, sir.
at
1
least
minus non-white.
correct. So it's a simpler way, right? This is nothing but 1 minus probability of
None
none
white.
is
None is.
whites. So none is white means what? We have to what is the total? 19C3. So we have to choose that 13 from 3 balls from 9 and 4, right? That means 30.
6C2, sir. 13C.
13C3. Okay. So why this is the simplest one? Because if you're saying at least one is white, that means there are 6 white, 4 red, and 9 black. So basically, what you have to do, you will do 6C1 into 13C2 divided by 19C3. Yes or no?
Yes, sir.
Yes. Sir.
Yes, sir.
Second case will be you will choose 2 white. Correct. 13C1.
Sir.
Then 19.
C3.
Is there any possible? Can I say 6C3?
6C3, yes.
Into 13C0 divided by 19C3?
Yes, sir.
Can I say 6C4 divided by 19C3?
So we need only 3 balls.
Correct.
3 balls, yes.
Only
So
3.
that's we don't need to do this. Okay. So you can actually cross verify from where in total we are drawing 3. So 1 is white, 2 are remaining. 2 is white, 1 from remaining. 3 all are white, 0 from remaining. Okay. So this part is clear to all of you. Okay.
Yes, sir.
Yes.
So
Yes,
the
sir.
last thing we will see it's called very important theorem from probability part called addition rule of probability.
Yeah.
So what it says actually, if I have, let's say, 2 events, let's say A and B, or you can say E1 and E2, anything, that's not a problem at all. So suppose I'm saying I have 2 events A and B. Okay. Then probability of A union B is nothing but probability of A plus probability of B minus probability of A intersection B. Okay. The formula is the derivation behind is I'm not going to do the whole derivation. I will give you some idea. Suppose this is your sample space. Okay. And this is A and this one is B. Okay. So what do you mean by A union B? So this whole part,
Yes, sir.
yes or no?
Yes, sir.
So if you see A union B, what we are doing, so probability of A plus probability of B. If I will write, so let's say A union B, I'm writing probability of A. Okay, so what is the probability of A here? Basically, this green, yes or no?
Yes, sir.
Okay, let me use some. So this green part I'm talking about probability of A, yes or no? Yes, no, right?
Yes, sir.
Okay. If I will say, probability of B, that means what? I'm talking about this yellow part, right?
Yes.
So if you see the intersection part, right? If you focus carefully, intersection part, we are counting twice, right? Yes or no? One for green, one for yellow, right? Yes, no, are you
Yes,
getting?
sir.
Yes,
So
sir.
if you will draw for green, I'm counting intersection part, right? And
Yes,
if
sir.
you draw yellow, again you are considering intersection part, right? So
Yes.
this union is nothing but, so this, since we are going to consider twice, so we will
Yeah.
subtract for one case.
Yes, sir. Green and yellow we have to subtract.
Correct. One,
Okay.
because we are counting twice, right?
Yes, sir.
Okay. Yeah. Give me a second. Okay, now so far so good, right? This part. Okay, so what if I will say, so this addition formula we saw just now, P of A plus probability of B minus probability of A intersection B. Suppose I'm saying A and B are disjoint, okay, or mutually exclusive. So what is the meaning of disjoint? Means A
Intersection is
intersection
empty.
B is 5.
Empty.
That means probability of A intersection B
Yes,
is
sir.
probability of 5, which is 0.
0.
So if A and B are
0, yes,
disjoint,
sir.
so can I say probability of A union B is nothing but probability of A plus probability of B?
Yes, sir.
Because this part is 0, I'm considering in case of this, right?
Yes.
So that's why in the third axioms of probability, you have seen, give me a second. Yeah, you can see if we have a set of disjoint event, right? In that case, union of this probability of union of these events will be addition of the respective probability. Okay, is this clear from where it came?
Yes, sir.
Right. All right. Okay. So is this clear so far? So far it is clear to all of you?
Yes, sir.
Okay.
Yes, sir.
Great, great, great. So there is something called, another thing called that's called equally likely events. Maybe this is very simple statement you can tell me without explaining it. So what do you understand by this meaning of equally likely outcomes?
The probability of all outcomes are equal.
Yes.
Yes, equal probability.
So basically I can say each outcome in the sample space is equally likely to occur, right?
Yes.
Okay. So let's say in sample space there is n events. I mean n outcomes. Okay. So what do you mean by this equally likely? Means whenever I will say probability of occurring 1, this is same as probability of occurring 2. This is same as probability of occurrence of 3 up to probability of occurrence of n. How much? 1 by n. Is there any example you can relate with this?
Throwing of a die.
Correct. So if you,
Tossing of a coin.
yeah, throwing of basically we are using a fair die. Fair die means there is no bias and all. Okay. So what is the outcome? 1, 2 up to 6. Okay. So what is the probability of getting 1? Is 1 by 6, which is same as probability of getting 2 up to probability of getting
1 by 6.
1 by n.
Similarly,
Yes, sir.
tossing a fair coin and all.
Yes, sir.
Okay.
Yes.
So I think so far it is fine.
Yes, sir.
Okay. So I think we have covered more or less every content, if I'm not wrong. Okay.
Yes, sir.
So yeah, so hopefully you got the idea from here, for this at least for week 7 content. Okay. So if you have submitted your week 6 assignment already, that's very good. If you haven't done, so submit and go for to attempt the like first was the content of week 7 and then attempt the questions from week 7. I will take one example from this addition theorem. Hopefully that will give you idea. Suppose I'm saying the probability. Whenever you are solving this kind of problem, just try to define the event probability that a student passes, let's say, statistics test is, let's say I'm saying 2/3, and probability that he or she passes both statistics and let's say a CT test. CT is computational thinking. Okay, it's let's say 14 divided by 45. Okay, this 2/3, 14 divided by 45. Okay, yeah, correct. So suppose I'm saying the probability that he passes at least, I'm just changing the scenario, at least one test is, let's say, 4/5. So what is the probability that he passes the CT test? Okay, so you have 2 minutes. Just read the question and solve.
It is at least or both the subject.
It's a at least. Here is at least, here is both. So what do you mean by at least? Anyone can guess?
The least
Union of
should be
S
what?
Sir, A union
Correct.
B. Sir, A
Correct.
union B is
and
14.
minus the intersection.
Yes,
No,
sir.
no, not minus. At least is the union.
Sir,
So the union.
Okay. So basically, let me do. Suppose you can define the events like this.
It is
Suppose,
either.
sir, if you go to the formula, sir, 14 A union B is like 14 divided by 45, isn't it?
not A union B is 14 divided by
We have
45.
P probability of B we need to take out, right?
Correct. We have to calculate.
Yeah.
Okay. So it's okay. Don't think it has been given in a sequence. So let's define events. So suppose I'm saying A is something like that. The student, he passes, let's say, statistics test. Okay. Okay. You can define event B, student passes the CT test. Okay. So from this question, what is given? What is the probability of A?
Sir, 2/3.
2/3. What is the probability of B?
We need to find out.
We have to calculate. What is probability of A intersection B?
Sir, 4/5.
Not 4/5. See,
Oh, okay.
intersection part is this here, right?
Yeah,
And,
yeah. 14
okay.
14 by yeah.
divided by 45.
Got
So what is the
confused.
A union B? A union B is given as 4/5.
4/5.
And we know addition theorem, probability of A union B is what? Probability
So
of
probability
A
of A plus probability
plus
of
probability
B
of B
minus
minus probability of A
A
intersection B. So from
sir.
here we have to calculate. So probability of A union B is what? 4
4
by
by
5,
5.
2 by 3.
Minus
Probability of B we have to calculate minus 14 divided by
14 by 44.
correct. So
14
probability
4
of
by
B
5 4 by 5 minus 2
yeah
by 3 plus 14 by 45.
yeah. So what you have to calculate whatever the answer will be.
Yes,
It will
sir.
give you the
0.4.
probability of that part. Okay.
So, sir, I did not understand this.
So where you didn't get?
First
So
part only.
this theorem is clear. This formula
Yes.
you know, right?
Yes.
So
Yes.
from the question it has been okay. So whenever question you are solving, just try to define the event. So if you define A as a student pass the statistics test, so probability of A is what? 2 by 3 for passing
Yes.
the statistics test 2 by 3. And let's say B as a probability of passing. I mean, let's say B is a student passes a CT test.
Okay.
So what is the probability of passing CT test? We have to calculate, right? So probability of B we don't know. And intersection means and. Okay. So what here you can see what is the probability that he will pass both part. So and means intersection is what? Which occur in both, right? A and B
Yes.
both,
Yes.
correct?
Yes.
So this is 14 divided by 45. And union is here at least one test. Means you can see how you are defining at least part in general.
So total minus the none.
No, that is that was a different. I'm talking at least I mean union of two events. I mean. See, you can say at least one of the events occurs, right?
Yes.
Yes or no? See, if you see what, let's say A is what 1, 2, 3. B is, let's say I'm saying 4, 5, 6. So what will be A union B?
The total.
1, 2, 3,
Okay.
4, 5. So can I say yeah? Can you say here from here at least one of the events? Yes or no?
Yes.
Yes or no?
Yes,
A
sir.
or B occurs. That's what we have given,
Sir,
right?
I didn't understand this.
So okay, what just focus on the element, number of elements, like
Yes, sir.
set of all. What it includes?
Sir, all
Both,
the
right?
set, yes, sir, from A
So
and B.
we can say at least A or B, right? So okay, it will verify. Suppose I'm saying 1, 2, 3. Okay, A is something like that. B is, let's say 3, 2, 4. Then what will be A union B?
1, 2, 3, 4.
Now is it fine?
Yes, sir.
At least one, correct? So
Oh,
okay, so this is something you can explore more on it. So here what
sir.
I have applied the addition rule of probability, which is a probability of A and B equal to probability of A plus probability of B minus probability of A intersection B. Actually, sometimes suppose this is given to you, this is given to you, this is given to you, you have been asked this one, or all three of right hand side is given to you and you have been asked the left side. Okay, this might
In the lecture, they mentioned either.
okay. Suppose I'm saying, see, if you just draw Venn diagram, it will be clear. Yeah. Okay.
So the screen
Okay,
is
so
not visible.
Your screen
yeah,
is not.
I have stopped actually. Okay, so if you draw, okay, so if you draw the union part, right, in Venn diagram, what we are considering both, right, at least A, at least B, right? Just think a bit actually. Say what is the meaning of at least A? We are going, no, we are including both, right? Kind of at least A or B means we are talking about A or B also. If you see Venn diagram, let me share my screen. So what I'm doing here, this is A, this is B. Okay. So if I will say at least one of the events A or B, or either A or B, that means what? I'm talking A or B, both, right? Okay. So this part is called A union B. If you see this colored one,
A
this will give you
intersection
the
B.
A and B only, right? Intersection part. Okay. This is Okay, so I think you covered more or less a brief concepts from week 7. Okay, how many of you have submitted the week 6 GA?
Sir, I submitted.
No,
Sir,
I
I as
submitted
well.
them, yes.
Okay, great.
Sir, where
Okay,
can I find the notes?
which notes?
The one which you just did.
I
Yes, sir.
think the session is not finished yet, right? Meanwhile, I can share in the G chat also. If you are okay, if you are able to understand the writing it later.
Yes, sir.
Yes, sir.
So I will share in the chat. Meanwhile, we'll upload on the portal under supplementary content. Okay. But meanwhile, let me share.
Yes, sir. Please,
There is
sir, upload, sir, in supplementary content, sir, only.
Yeah, I will upload it later after
Yes,
this
sir.
session. Meanwhile, as of now, let me share in the chat. Okay.
hello.
Yes.
There is a one formula I to infinity that you said actually after you will be refreshing that formula. Yes. That
So
actually
infinity
I don't
means,
understand.
yeah, infinity means lots of events you have. You don't know. It's a, we're talking about sequence. It
There is
can
a
be
formula. There is a formula pertaining to the infinity.
okay. Whenever you are seeing any formula, right? Just try to do for two events. Like for simple example, suppose I told you, suppose you have two events. Okay, let's say A1 and A2. Okay, by the additional rule of probability, what I will write, A1 union A2 is what? Probability of A1 plus probability of A2 minus probability of A1 intersection A2, right?
Yes.
Now, if I'm saying A1 and A2, they are disjoint, then probability of A1 intersection A2 will be what?
Hi.
Probability. A1 intersection A2 is 5. So I will take probability on both sides. So it will be probability of 5, it will be 0. Right?
Yes.
So what you will get from here, probability of A1 union A2 will become probability of A1 plus probability of A2. Yes or no?
Yes.
So this is for two events. So can I write probability I is equal to 1 to 2 AI equal to summation of I is equal to 1 to 2 probability of AI? Yes or no?
Yes. Yes.
So if you have sequence of events which are mutually exclusive and disjoint, you don't know the exact number, then can I write probability union of I is equal to 1 to infinity AI same as summation of I is equal to 1 to infinity probability of AI?
Yes.
Correct. So this is the generalization of this. Okay.
Okay. Okay. Now understand.
Fine. Okay. Then all right then. I hope you got the concepts from week 7. Okay, we'll meet in the next session. So before coming to the next session, so try to solve more questions and come up with some doubts. Okay.
Sir, when will you
Sir,
teach in the
excuse me.
next session?
So by SPC EMQ6 practice, everyone is facing. Yeah. So I have sent one announcement, right? I hope everyone got right how to submit
Yeah,
and all.
for no means I guess we also got an
Update.
in the inbox that week 5 there's one error in one assignment.
Yeah,
So
so
in
for week 5, there was something issue. So
Some
that's why
errors.
we are not going to evaluate week 5. But for week 6, there will be, I think we have sent one announcement, right? 80-20 weightage.
so in
So
my
just,
case,
hmm.
there is 0, 1, and 2 practice assignment. I am able to submit 1 and 2, but 0 it's not showing any test cases. Even if I put the same text file, it will show 0 test cases.
For practice, no,
Yeah,
submit,
EMQ.
submit. Okay, you can practice in the graded one, but submit the for uh, EMQ case. Sorry, graded part. Okay. So okay, have you seen that
Sir,
instructions
I didn't
related
understand.
to?
Sir, I didn't understand that 80-20 it is talking about, like they are saying that previous case. What do you mean? What does mean by previous case, sir? I didn't understand that. How
Previous
they
case
going to?
means?
Like how they're
Means
going to
it's
be.
written that practice assignment 180% to 20% weightage.
No,
And
it's
there's
not
They are,
also
that.
one
they are no,
zero.
no, they are not talking about practice assignment. Practice
It's
assignment
for
is not been graded.
EMQ,
yeah,
EMQ.
Yeah,
yeah,
EMQ I'm
EMQ.
talking about. EMQ,
Yeah,
they are talking about the previous week. That means week
see,
4.
there were EMQ assignments in week 5, okay, or in week 6 also, both, right?
Yes, sir, graded assignment, EMQ graded assignment,
Yes,
both
sir.
in
Correct.
week 5. So
Yeah.
week
So
5 they are not going to calculate as
correct. So there
they have
was
made.
some issue. That's why we decided, I mean, justice for everyone. So we decided not to take, evaluate. We will evaluate only assignment part 1 for week 5 only. For week 6, we are going to suppose you have submitted in week 6. There are 2 assignment, right? 1 and 2.
Yes.
Second one is for EMQ, right?
Yes,
So
Yes,
sir.
sir.
suppose you got 10 marks in assignment 1. Okay. So what will the 80% of 10 marks?
80% of 10 marks, sir.
8
Sir,
8
8,
marks.
sir.
8. So it will be we will add 8 from there and 20% weightage from whatever the marks you suppose you got you know uh, for okay, what will be the 20% of suppose you got full marks in assignment 2?
2 marks.
2 marks, so you will get 10 marks total. Okay,
Okay.
that
I
is
thought
the
I thought they will be calculated practice assignment also.
Sir,
no
in
no no no
exam, sir, do we have to do the EMQ type of
no
thing?
no no in exam there will not be EMQ, there will not be questions related.
So what is this peer review, sir?
So peer review, once the due date will be over, right? Once you will submit your assignment and submission due date will be over. So once you will check your portal, so random you will get at least 3 set of students. I mean work of 3 students. Okay, you have to review their activity and you have to give the marks according to the grading criteria which we have mentioned for that particular activity. Okay, so it's a peer review things, you have to do peer, we are not going to do manually
Sir,
part.
it's not
Sir,
compulsory.
how are we going to, sir, evaluate our peers assignments, sir?
It will once the
They
due
will
date
upload.
of some.
Will they going to upload the like any
Okay,
assignment?
suppose, okay, what I'm saying, suppose 10 of us have submitted the extra activity. Okay,
Yes, sir.
suppose today is the due date. Okay, till today you have submitted from your side and every else, suppose 10 people have submitted. After today, once due date of submission will be over, you on a portal you will get at least 3. Suppose you got one activity of mine, one activity of, let's say, Kriti, one activity, let's say, of Subham. Okay, then you have to review hours activity, you have to give marks for our activity according to the grading pattern. Okay, similarly your copies will randomly assign to someone else. Okay, I mean suppose Abhishek will get some other 3 copies of other 3 people. Okay, that is something you have to do. Okay, make sure you have done at least 3 peer review from your side. If you are not, you have just submitted your activity, you haven't done any peer review, you will get the 0 marks
Sir, I have a question.
Sir, my
irrespective
question is
of.
like, is it going to be show like our
Yes,
peers
yes, it will be, yeah,
assignment?
it will be visible on your portal.
Oh, okay, okay.
Okay, so
Sir,
I think you are not able to share a screen right now. I think so. What I'm okay, it's not visible for me also. Let me check from the last. One second, give me a second.
Sir, week 8 stats also not released yet. Will it be released tomorrow?
Yeah.
Thank
sir,
you.
I
Thank you
have
so
a
much.
question, sir.
Yes.
Sir, like the activity question, is it needed to give our own picture and own things? Like we are making a portfolio, can we do a fake one?
Our own pitch means what you
Like,
say?
sir, we are making portfolio, right, sir? So we need to
Hmm.
add picture and we need to add where we live, what's our number, what's our address, and all those information.
No. That's your personal information.
So we
So
don't
just
have to do that,
just
right, sir?
just see the Andrew sir video you have seen.
Okay, sir.
Okay,
And
so
sir, like
sir,
it's not compulsory.
yeah, it's not. You have to basically create a subsection where you have to mention about activity, or you can mention about the statistics part, not beyond that.
Okay,
Sir,
sir.
after submitted the EMQ, what is the evidence that you've been submitted? After refreshing and sign out again signing in, there is no proof that I have been submitted or not. Again, it's showing blank. So how do I know that is it's submitted? But it's
No,
when I
so
submitted, it's showing submitted.
you,
But when you are signing out from the portal again, I'm signing in, checking the EMQ again, it is not showing anything. I mean, no evidence of that I submitted.
oh, is it? One second. Is it for everyone?
Anybody
There's
can
no
help me out?
indication, sir, whether we have
No,
There
sir.
is no
submitted or
No,
not.
sir. No,
indication. Just the
Yeah, that's
summary option.
One
सर वहाँ पे
Summary arrow.
ऑप्शन एक मिनट सर वहाँ पे ऑप्शन आता है सक्सेसफुल सबमिट करने का
Yeah, whether you are submitting or not. That's
हाँ
the
सबमिट करने का जो पॉपअप होता है ऑप्शन मतलब सर योर असाइनमेंट हैज बीन सक्सेसफुल प्लीज
submitted.
Yes, but
That,
when
There
we,
is like
we
showing.
log
blue,
in, it doesn't show.
there is a blue dot in that,
नो नो
you
नो
know.
रिफ्रेश करने का फिर से ब्लू डॉट में शो करता है हाँ योर असाइनमेंट हैज बीन सबमिटेड
one second.
Yeah,
I'm
it
going
shows
to
blue dot.
No, sir. We
Yes, sir.
get blue dot.
one
हाँ,
second.
blue
I'm going
dot.
to share my screen. Can you see my screen? Okay. I have
Yes, sir.
selected EMQ test correct one file. Okay, basically it's here from here you have to select that zip file. Then here you have to choose file. Okay, it's gone. Let me stop my screen and I will select the file. Then I will do the
Nobody mentioned in this information. Yes.
Okay, suppose you can go here as a test run, then you will see something here. Okay, and then okay, you can see something like this, something you can do, and you can submit.
So
right?
the test run is for whether the file is supported or not. So
Correct,
if it is
correct,
showing
correct.
like this, so you can understood that file is
Yeah,
supported.
file is supported. Okay, then you
Thank
can
you.
choose
Yes.
your file and you can submit. Right, just choose your file and then submit. Okay, you can see your file has been like it's not visible now. So what you can do, you can
Sir,
choose
actually
file.
in corner, sir, they have given, please update your like screen. You need to update and then you need to upload the file, sir. This is I guess this is the old version, I guess.
Yeah.
That's why the test run is not I mean running in this portal, sir.
Correct. So I think I've chosen the file. Let
Yeah,
me. It's
you
not.
need to scroll it a little bit, sir. Scroll up, sir. Scroll up. Scroll up, sir. Scroll up, sir. Go to the top part, sir.
Yeah, go to the
Try new user.
Okay, try new UI. Okay,
user interface, sir.
Yes, here only we are able to upload.
Understood. Yeah. Correct. So make sure you are going to submit. Okay, yeah, this file,
Yeah,
this
choose
file,
the file and
understood.
then you
Yeah,
have to
then test
run.
run and then submit. Yeah, good. Yeah, very good.
Sir, so we need to do this way because sir, I did and it's showing that it is submitted.
Yeah, if you have submitted, that's not.
So once it's submitted, means that's it, right?
See,
Correct.
if blue color will showing, like if
Yeah.
you refresh the page and blue color dot is showing, then your assignment has been submitted.
Yeah.
Where is the blue color? Everything blue color only.
Blue color circle in that
Once you
graded
complete your
assignment or
There's one yellow
graded
clock.
assignment.
There's a one yellow clock. Instead of that, it will show a blue
if someone
circle.
show that there is a screen, I can like show it. If someone share the screen, I can show
Okay.
it.
Let me share my stuff. Okay, I have submitted EMQ for me. Okay, this one, right? So you
Yes,
can
sir.
see.
If you scroll down, sir. I mean, go week 1 assignment or week 2. Some scroll it down, sir. Yeah, see, clock yellow color is showing, right? Clock is showing a yellow color.
Okay, you're talking about 6, right?
Yeah, 6. So yellow color is showing right now.
Yes.
So once you submit, it will going to be blue color.
Okay. Okay, that is the only indication, right?
Yes.
Yeah.
Okay.
Or else I think you can submit also, right? See, if you are submitting, you will know that you are submitted. Okay, that's the another thing.
Submission full option तो यहाँ पे आ रहे हैं.
Yeah.
But sir, I am getting that blue color circle.
एक बार पेज पर रिफ्रेश कर लो फिर से हो जाए दिखने लगे.
There's also
Sir,
summary
thanks.
option. Summary,
Thanks,
there's a
buddy.
drop
Yes,
down.
thank you.
Yeah, you can do here submit.
You can refresh. Once you refresh, it will automatically show your blue color tick. If you submit your graded assignment, if you not submit, it will not going to show you.
Then it is common for all the activity,
So
practice,
here you
everything.
can
Yes,
see,
yes.
here you
Yeah,
can
so
see it's
you
a
can see,
blue
yeah.
blue button, right? You can see.
Blue
Yeah,
button.
yeah.
Okay.
Yes, yes.
Now you can see because I have submitted my file. Okay.
Thanks a lot, guys. Yes.
Yeah. Thank you. Thanks, Vishnu.
Sir, one thing.
Okay. Huh.
Sir, I'm thinking, what is the meaning of a public test and private test, sir?
I'm not sure about this. It's
Sir, that test case regarding that EMQ, sir, the test passes. So public are,
Yes, sir.
for example, we have
okay.
submitted.
So private case is like so. Understood. Yeah. Actually, in backend, how we are evaluating those things. So public test is something you will see. Whatever the, I mean, it will be visible on your portal. I mean, on your screen. You can say. Private
Yes.
will not be visible on. Okay. It's for backend purpose.
Okay, sir. Okay.
Okay. Okay. All
Sir,
right.
sir, there is
Okay,
a
sir.
small doubt for me, sir.
Hmm?
Sir, it's regarding last week, sir, regarding some permutation and combination problem.
Hmm.
So the thing is, when we say, let's say we have been given 6 white, 3 red, and 2 blue balls, and we
Okay.
are asked to select 3 white balls.
Hmm.
So in this case, are we considering those 6 white balls to be different or to be same, sir?
No, see, if it's about same or similar, identical, it will be clearly mentioned. So as of now, it means you have 6 balls, 6 different balls. Out of those 6 balls, you are just selecting 3. Kind of, you can assume you have some 3 t-shirt of same color, and you are choosing any 3 to decide your dress for upcoming 3 days. Okay, something like that.
Basically, we are considering them to be different, sir.
Yeah.
Okay, sir. Thank you, sir.
Okay. Yeah. Okay. Thanks all. Thank you. Hope
Thank
you
you,
got
sir.
the
Good night,
idea.
sir.
And,
Thank you,
yeah.
sir.
Yeah. Good
Thank
night,
you, sir.
buddy.
Good
Good
night.
night, buddy. Yeah. Good night.
Thanks,
Bye.
guys. Thanks, sir. Bye.
Thank you. Yeah. Bye.
Thank you, sir.
Thank you.